To better understand coordinate geometry, you need to understand how formulas are derived in it. Memorizing formulas won't help. A little twist of simple question could make such person go off balance. In this lecture, I will be proving some of the formulas in coordinate geometry with detailed explanation. Do well to follow up with apt attention. Before diving into the proof, you need to understand that the distance between 2 points on a vertical or horizontal level is the difference between the points. What I'm saying in essence is this: given any 2 points on the x-axis, say point x1 and point x2, to calculate the distance between the points, we just take the difference between them, that is, x2 minus x1, and that is it. Also, if we are to calculate the distance between the points y1 and y2 on the y-axis, we just take the difference between them, so, y2 minus y1 is the distance between the points. The question is this: how do we calculate the distance between points that do not lie on the same axis? Let's see how this works. We already have the points, but let's better define it as point A x1, y1, and point B x2, y2. We want to calculate the distance between points A and B. The first step in this case is to interpret the information on the plot. Point A is the intersection between x1 and y1. Join the lines. And point B is the intersection of line x2 and y2. Join this also. Since we are to calculate the distance between point A and point B, let's join the points. If we extend the horizontal line through point A, a meaningful right-angled triangle emerges. On the y-axis, we understand that the distance between y1 and y2 is the difference between the points, so, y2 minus y1. We also see that the same distance is formed by one side of the triangle, so label the side as y2 minus y1. The same happens on the x-axis. The distance between points x1 and x2 is x2 minus x1, and this forms one of the sides of the triangle. So equivalently, we write x2 minus x1 as the length of the side. Don't let us be carried away. Our aim is to calculate the distance between point A and point B. At this stage, let us look around to see if anything can be done to get the aimed distance. The triangle here is a right-angled triangle, and we already have the expression for two sides of the triangle. We want to find the expression for the third side, which is the hypotenuse. Forget not the Pythagoras theorem, which is always the answer to problems of this kind. The Pythagoras theorem implies that the square of the hypotenuse is equal to the sum of the squares of the remaining two sides of the right-angled triangle. In this case, the first side is x2 minus x1, and the second side is y2 minus y1. So, the hypotenuse, which I denote as c, is the square root of x2 minus y1 square, plus y2 minus y1 square. And this is the expression for the hypotenuse, which is the distance between point A and point B. Finally, the distance between any 2 points with coordinates x1 y1 and x2 y2 is equal to square root of x2 minus y1 square plus y2 minus y1 square. So, the proof is complete. Let's see how we can prove the formula for the internal division of a straight line. We start by plotting the curve, with the x and y values included. Assume we have 2 points A and B. Say ax1 y1, bx2 y2. Locate the intersection of both on the plot. Now we have the line by joining the points A and B. Also, assume any point on the straight line. And let us denote the ratio of the division of the lines by M and N. Join the horizontal and vertical lines as follows. The coordinate of the point is xy. We should take note of that. Y can be traced to the y-axis, and x to x-axis as follows. We also need to assign an angle theta to the upper triangle. With the idea of similar triangles, we see that the angle repeats on the second triangle. The distance between x2 and x is x2 minus x. Also, the angle between y2 and y is equal to y2 minus y. The distance between y1 and y is y minus y1, and the distance between x1 and x is x minus x1. By applying simple trigonometric properties on the first and the second small triangles, in terms of the sine function, we have these. Sine theta equals x2 minus x over n. And sine theta equals x minus x1 over m. Let's do this also in terms of the cosine function. Cos theta equals y2 minus y over n. And cos theta equals y minus y1 over m. Now we have 2 of sine theta, and 2 of cos theta. Let's start with the sine. Sine theta equals x2 minus x over n, and sine theta equals x minus x1 over m. Let us equate the right-hand sides, since the left-hand sides are equal. So, x2 minus x over n equals x minus x1 over m. Let's perform simple algebraic process to make x the subject of formula. Start by cross-multiplying. We have mx2 minus mx equals nx minus nx1, and when we bring nx and mx together, also nx1 and mx2 together and factorize, we arrive at m plus nx equals nx1 plus mx2. Divide both sides by m plus n. So x equals nx1 plus mx2 over m plus n. This is for the x-axis. To get the point on y, we consider the pair of cos theta also, then repeat same process for it. Cos theta equals y2 minus y over n, and s dot cos theta equals y minus y1 over m. By equating these, we arrive at y2 minus y over n equals y minus y1 over m. To make y the subject of formula, start by cross-multiplying. We have my2 minus my equals ny minus ny1, and when we bring ny and my together, also ny1 and my2 together and factorize, we arrive at m plus ny equals ny1 plus my2. Divide both sides by m plus n. So y equals ny1 plus my2 over m plus n. So, this is the coordinate of the division on the y-axis. Now, we have the coordinates of the division in the ratio mn on the x and the y-axis. Finally, the coordinates of the division of a line AB is given by the following. On the x-axis, nx1 plus mx2 over m plus n, and on the y-axis, ny1 plus my2 over m plus n. A special case of this result is when we are to calculate the coordinates of the midpoint of the line. In this case, we should know that m equals n, since we are considering the midpoint. So, we continue by substituting all n in the formulas with m. X equals mx1 plus mx2 over m plus m, and y equals my1 plus my2 over m plus m. We factorize the expression for x and for y by bringing out the common variable, which is m. So, m cancels out from the expression. We now have the formula for the coordinates of the midpoint. For x, x equals x1 plus x2 over 2, and for y, y equals y1 plus y2 over 2. Using the formula for the internal division above is more general, and more reliable. From it, we can answer various questions regarding internal division and the midpoint itself, that is why you need to understand it. How do we calculate the angles between two lines in terms of gradient? Let's see how it goes. As usual, get started with a well-labeled diagram, and look for possibilities in the diagram to get it done. Let's assume a slope from any point on the plot. Label the gradient as m1. Also, let us assume the second slope, and label it as m2. Let the slope m1 and m2 intersect, since there must be relationship between them, and their angle would work out that. Let us also draw a perpendicular line from their point of intersection to the x, to form a right-angle triangle, as we know that there are usually a lot of possibilities when working with a right-angle triangle. Let the angle formed by the first gradient to the horizontal be denoted by θ1, and the angle by the sin θ be denoted by θ2. There is a smooth relationship between the angle θ and the gradient. That is, m equals tan θ. Let's have this in mind. To further label this diagram, let's use the values we have on the plot, to derive others. The triangle by the right-hand side is a right-angle triangle, so, to get the third side, we subtract θ2 from 90, and we have 90 minus θ2. When we also consider the largest triangle, which is a right-angle triangle also, the unknown angle is 90 minus θ1. But we are most concerned about the angle here, which is the angle between the two gradients. So, we subtract the angle of the second part from the total angle to get the required angle, and this is equal to θ2 minus θ1. There is another way to do that. The angle here is θ2, so, the angle here is 180 minus θ2. This is a triangle, and the sum of the angles of a triangle is equal to 180 degrees. To get this part, we derive an expression for it in terms of the remaining two sides, so, it is equal to 180 minus θ1 plus 180 minus θ2, and this further simplifies to θ2 minus θ1. All road leads to Rome. As stated before, gradient in terms of the angle of inclination is given as m equals tan θ. So, for θ1 and gradient 1, tan θ1 equals m1. And for θ2 and gradient 2, tan θ2 equals m2. Since our aim is to find the angle between m1 and m2, which we further discovered in term of θ to be θ2 minus θ1, let's use the tangent formula below. Tan A minus B equals tan A minus tan B over 1 plus tan A tan B. A is equal to θ2, and B is equal to θ1. So that we can get θ2 minus θ1, which is our aim from the start. Tan θ2 minus θ1 equals tan θ2 minus tan θ1 over 1 plus tan θ2 tan θ1. But we already have tan θ2 is m2, and tan θ1 is m1. All we just need to do is to replace these in the right-hand side expression. So, tan θ2 minus θ1 equals m2 minus m1 over 1 plus m2 meters 1. And to get the angle, which is θ2 minus θ1, we take the arctangent of both sides, so, θ2 minus θ1 equals arctan m2 minus m1, over 1 plus m1 meter 2, and this is the conclusion. We know that the equation of a line can be expressed in the form, y equals mx plus c. M is the gradient while c is the intercept. Also, the equation of a line can be expressed in terms of intercept. The x-intercept is the point on the x-axis where the line cuts the axis, while the y-intercept is the point on the y-axis where the line cuts the y-axis. We want to generate the equation of a line in terms of these points. Let's use a more general method of getting the equation of a straight line. y minus y1 over x minus x1 equals y2 minus y1 over x2 minus x1. For y-intercept, x equals hey, and y equals 0. Let's regards these as x1 and y1 respectively. Also, the x-intercept occurs at the point where x equals 0, and y equals b, regard these as x2 and y2. Now, by substituting these into the equation, y minus 0 over x minus hey, equals b minus 0 over 0 minus hey. This implies that y over x minus hey, equals minus b over hey. Cross multiply and modify. Hey y plus bx equals hey b. Divide through by hey b. So we arrive at the equation, x over hey, plus y over b equals 1. This is the equation of a line in term of the intercepts. Let us consider one more before this lecture ends. Parallelism and perpendicularity. Consider two parallel lines. These lines are parallel because they can never intersect when prolonged to any length. If one of these lines is shifted and placed on the other, they both will lie on a straight path, and there won't be any angle between them. So we say, the angle between two parallel lines is 0. Now, let us make use of the formula we derived for the angle between two lines in the previous proof. Tan theta 2 minus theta 1 equals m2 minus m1 over 1 plus m1 meter 2. Since the angle between them is 0, theta 2 minus theta 1 is 0, then tan 0 equals m2 minus m1 over 1 plus m1 meter 2. Since tan 0 is 0, the right-hand side is equal to 0. Cross multiply, so m2 minus m1 equals 0. Bring m2 to the other side, so m1 is equal to m2. We can now conclude, if two lines are parallel, then m1 is equal to m2. For perpendicularity, the angle between the lines must be 90 degrees. Two lines are perpendicular if the angle between them is 90 degrees. The same formula we used for the first applies here also. Tan theta 2 minus theta 1 equals m2 minus m1 over 1 plus m2 meters 1. They are perpendicular, so theta 2 minus theta 1 is 90 degree. Tan 90 degree equals m2 minus m1 over 1 plus m1 meter 2. But tan 90 gives a numerical expression of 1 over 0. So, we cross multiply from this stage, and we arrive at the following. 1 plus m1 meter 2 equals 0. Make m1 the subject of formula, m1 meter 2 equals minus 1, and this implies that m1 equals minus 1 over m2, and the proof is complete. Conclusion, if two lines are parallel, then m1 equals m2. Also, if two lines are perpendicular, then m1 equals minus 1 over m2.
Finish and win the war. I'm gonna